In this video, we're going to take a look at rules of exponents with regards to dividing expressions. So let's say we had the expression 4x squared y to the fourth over 3x y squared. The idea behind dividing is very similar to what we discussed with multiplying. You should really understand first that x squared is still x times x, and y to the fourth is still y times y times y times y. So if we were to take the numerator and write that out in expanded form, and then take the denominator and write it out in the same way, 3 times x times y times y, we can look at that expression very carefully, and we could see, oh, there's an x on the top, there's an x on the bottom. They reduce to 1. A y and a y, they reduce to 1. A y and a y, they also reduce to 1. So I'm left with 4x y times y over 3, which is the same thing as 4x y squared all over 3. Notice that the 4 and the 3 didn't change because I can't reduce 4 over 3 like I would normally reduce a fractional. So the general idea here, if you didn't realize it already, is that when we're looking at dividing common bases, we actually just look at the exponents, the 4 and the 2 on that y, and subtract them. 4 minus 2 equals 2. And with the x's, the 2, and there's no exponent on that x in the denominator, but that's really a 1. 2 minus 1 gives me x to the first. Now let's try this example. So first, I'm going to look at the 3 over 18. And I'm going to realize that 3 and 18 both have factors of 3. So that can be reduced to 1 over 6. A tendency of a lot of students, since they know 3 goes into 18 6 times, is to just write 6. But it's not actually 6, it's 1 over 6. Now looking at the x to the fifth over x to the third, now I could expand this if I'd like, or I could just say, well, I have 5 x's on the top, I have 3 on the bottom. That's going to leave me with x squared on the top, and again, that rule that we spoke of, 5 minus 3, gives me 2 when I subtract exponents. Again with the y's, 9 minus 7 also gives me 2, so I'm also going to have a y squared in the numerator. So my final answer is 1 x squared y squared all over 6, or I could write that as x squared y squared all over 6. That would also be appropriate. That 1 is there, even though I don't write it. So you may be wondering what happens when you have more of a variable on the denominator than you do in the numerator. So thinking about that original idea of expanding the expression, first of all, I'm going to look at 4 over 22 and I'm going to realize that 2 goes into both of those. So that will actually reduce to 2 over 11. Now I'll move on to the x's. X cubed over x, that's just x to the first. 3 minus 1 gives me x squared. Now, when I look at the y's, I realize that there's actually 9 y's in the denominator and 4 y's in the numerator. One of the tricks I can do is I could say, okay, let me just take the bigger exponent, 9, subtract 4 from it, I get 5, and I just realize that since there were more y's in the denominator, my 5 y's are going to remain in the denominator. And if I think about that, if I were to write y times y times y times y in the numerator, and then write 9 y's in the denominator, I would cross out 4 of them, and I would be left with 5 of them in the denominator. So let's take a look at one last expression. Again, I'm going to look at my coefficients. 3 over 15 reduces to 1 over 5. Now, the a squared over a to the 7th, what I'm going to do is I'm going to choose my higher exponent. So 7 minus 2 is 5. So I have a to the 5th in the denominator. Now move on to the b's. The 4 is higher. 4 minus 3 is 1. So I have b to the first in the numerator. And last but not least, looking at my c's, 12 minus 9. 12 is higher, so that's 3. And since there are more c's in the denominator, I'm going to have c to the third in the denominator. So my final answer is b to the first over 5a to the fifth b cubed.